Hi, in this video I would like to solve IB Mathematics High Level Test Paper 1. In this test I will discuss the idea behind each question when we attempt to solve it. So in section A, question number 1, you are given 3 planes. This is the first one, and that's the second one, and the third one, and you are asked to find the coordinates of the point of intersection of these planes. So when you have 3 planes and would like to find a point of intersection, there are many ways to do it. First one called by elimination. So in this method, what we do is first we try to eliminate 2 variables and find 1 variable, and then find the second one, and then find the third one. So let's look at it carefully here. If you place the first equation and the second equation on top of each other, you will notice that the 2 variables x and z in these both equations have the same coefficient. So we can eliminate both of them simultaneously by subtracting the 2 equations. So we have x minus x is 0, and then we have y minus y, it's just y plus y, which is 2y. And then you have z minus z is just 0. Equality goes down the same, and then 3 minus 5 is minus 2. So now we have one equation with one unknown. You can easily use algebra to divide this by 2, divide this by 2, and then the answer will be y equal to minus 1. That's the first coordinate here, y. Then if you take and then you substitute y in 2 of those equations, so what you do is now in any of the 3 equations, then what you get is x, the first one, x minus y plus z equal to 3. So you take the minus 1 to the other side, collect terms, then this becomes x plus z equal to 3 plus 1. So you have x plus z equal to 4. And then you can take y equal to minus 1 and substitute in the third equation. So what happens is you get x minus 1 plus 2z equal to 6. Then you take the minus 1 to the other side, and what you get is x plus 2z equal to 6 plus 1. So x plus 2z equal to 7. So now we have 2 equations with 2 unknowns. Then you can solve it by placing them below each other. So you have x plus 2z equal to 7 and x plus z equal to 4. We subtract because x have the same coefficient, so we can eliminate the x first, and then you have 2z minus z is just z, 7 minus 4 is just 3. That's the second coordinate we found. And then what you can do is you can take the z and plug it in any of these two equations to get x plus 3 equal to 4. So x equal to 4 minus 3. Take this to the other side, and then x equal to x equal to 1. So the coordinate, so the intersection point of the three planes is given by 1, minus 1, and 3. That's it. Question number 2. Here is a question about probability, and we need to use probability theory to solve this problem. You have the faces of a fair 6-sided die, which are numbered 1, 2, 2, 4, 4, 6. Let x be the discrete random variable that models the score obtained when this die is rolled. Complete the probability distribution of the table x. So the x values, it's either 1 or 2 or 4 or 6. So what is the probability that x equal to 1? So think about it. Now, for the probability that x equal to 1, since you have 6 faces, the probability that x equal to 1 is 1 over the 6 faces. It's 1 over 6. 6 possibility. So remember that the probability that x equal to little x is equal to the number of elements in the group x equal to little x divided by the number of elements in the sample space. So the number of elements in the sample space, it has 6 sides, so there is 1 over 6 chance to get this side. What about 2? Now for 2, we know that we have 2 sides that has a number 2, so it's 2 sides divided by 6, which is equal to 1/3. So there is a 1/3 chance of getting 2, which is higher than the 1 because there are 2 faces. Similarly, for the 4, 2 over 6, which is 1/3, and finally 6 is just 1 over 6. So if you add them up, you should always get 1. To make sure that our answer is correct, you add them up. So 1 over 6 plus 1 over 6 is 2/3. 2 over 6 plus 2/3, and 2 over 6 is 1/3 plus 2/3, which is equal to 3 over 3, which is equal to 1. Question B, find the expected value of x. Now the expected value of x, so this is the expected value of x, is equal to, can be written as the sum of the product x times the probability that the random variable x equal to x, small x, where little x belongs to all the sample space values. So the first value is 1. Okay, so we have 1 times its probability of occurrence, which is 1 over 6, plus 2 times the probability of getting 2, which is 1 over 3, plus 4 times the probability of getting 4, which is 1 over 3, plus 6 times the probability of getting 6, which is 1 over 6. So let's now simplify. This is 1 over 6 plus 2/3 plus 4 over 3 plus 6 over 6. So let's make a common denominator, which is 6, the 1 plus, so you multiply by 2, you multiply by 2, you multiply by 2, you multiply by 2. 2 times 2 is 4, plus 2 times 4 is 8, plus 6, which is equal to 4 plus 6, 10, 8 plus 1 is 9, so 19 divided by 6. That's the expected value. And that's it. Question number 3. You have a rational function defined by f of x equal to a plus b over x minus c, where all the parameters a, b, c belongs to the set z, which is the integer set, and x is a real number except the value c, because at c you have an undefined value. Now this is the diagram of f of x, a plus b over x minus c. So we know that at x equal to c, this is not defined, because something over 0 is not defined. So if you look here, you can see that at 3 in this graph, this is, you have an undefined case. Okay, so 1 goes up, 1 goes down at 3, which means that there is no defined value. So state the value of a and the value of c. So the value of a, okay, so how do we find it? The value of c is clear, so we know we can find c from the, this is called the vertical asymptote. And this happens at the zeros of the denominator. So this is when x equal to c, which is the case when x equal to 3. So in this case, c equal to 3. What about the value a? So we know that as x goes to infinity or minus infinity, we know that the curve approaches this asymptote, which is 1. So as x approaches infinity, then it's clear that the limit as x approaches infinity of f of x is equal to a, because as x becomes large, we know that f of x equal to a plus b over x minus c, then this behaves when x is much larger than c. When x is much larger than c, then the term x dominate and this behaves like a plus b over x. And also, as x becomes large, which is greater than b, then this term approaches 0, becomes very small, so the behavior becomes a. So that's the horizontal asymptote. So we call this the horizontal asymptote. In this case, a equal to 1. Now question B, find the value of b. So we can rewrite the equation f of x now by substituting a, which is 1, and substituting c, which is 3. So we have, in order to find b, we need to create a one equation to solve for one unknown. So what we can do is we can use this point. So this is x, and we know that this is f of 1. So when x equal to 1, f of 1 is equal to 0. So we can have this formula. So sorry, this is f of x. So we know that f of 1 equal to 0. Let's substitute. This is 1 plus b over 1 minus 3 equal to 0. So 1 minus 3 is just minus 2. So we can take b over minus 2 to the other side, becomes positive. So we'll have 1 equal to b over 2, and then cross multiplication, this gives me b times 1 is b equal to 2 times 1, which is 2. So the answer is 2. And that's it. Now let's solve this problem. Consider the vectors a equal to I minus 3j minus 2k, b equal to minus 3j plus 2k. Find a cross b. So how do we find this value? So we can use the rule a cross b equal the determinant of I, j, and k. These are the unit vectors. And first we put the coefficient of the vector a, which is equal to 1 minus 3 and minus 2. So these here, as you can see, here I have 1, here I have minus 3, here I have minus 2. So here there is no I, so it's 0i, so 0, minus 3, and 2. So we can place them below each other, 0, minus 3, and 2. The question is, how do you find the determinant? So first, so a cross b, if these are of course two vectors, then the answer is a vector, another vector. So since it's a vector, so we will have I coefficient, j coefficient, and k coefficient. So the first one, to find the first coefficient, so what you do is you cross this first row and you cross the first column, and then you determine the determinant of this matrix, 2 by 2 matrix. So you will have determinant of -3, -2, -3, and 2. And remember that the rule is you put this little sign here, plus, minus, and plus. These are sign multiplied by the coefficient of each dimension. So for dimension J, first you have the negative sign coming from here, multiplied by the determinant of this 2 by 2 matrix. So you will have 1 minus 2, 0, 2. And then I have plus the determinant that's given by, of course there's a plus here, and then I have the determinant of 1 minus 3, 0, minus 3. So continue the solution. The determinant here is you have -3 times 2 minus -2 minus 3, and this is I, minus 1 times 2 minus 0 times -2, J plus 1 times -3 minus 0 times -3, and that's K. And then the answer will be -6. So this is -6, this is -6, so that will be -12I, and here 1 times 2, so 2 minus 0 is just 2, so -2J, and here 0 cancel out, and then -3K. And now how do I just, an extra knowledge, how do I check that my answer is correct? Now remember that when you have two vectors A cross B, it generates a vector N, which is normal to A and B. So it will make a 90-degree angle with both A and B, which means that the dot product of A dot N is equal to 0, and B dot product N is also equal to 0. So let's check. So A is, the vector A is I1 minus 3 and minus 2. Multiply for the dot product, you multiply each dimension coefficient with each other and then add them up. So you have 1 times minus 12, then plus minus 3 times minus 2 plus minus 2 times minus 3. So here we have plus 6, here we have plus 6, here we have minus 12. So minus 12 plus 6 equal to 0. So that's correct. Same thing goes for B. So B dot N, B is 0 minus 3, 2. So you will have 0 times minus 12 plus minus 3 times minus 2 plus 2 times minus 3, and that's equal to, so we have here 0, here I have plus 6, and here I have minus 6. 6 minus 6 is 0, so that is correct.